Today, let's just program and create our own image classification model in the scope of Pokemon. Uh, I haven't done this yet. I don't know what it's going to turn out like. And I don't have this planned. So you'll probably see me fumbling around as usual. I'll try to edit out as much as possible. And I do want to try local LLM coding again. So I have Klein set up here on my VS Code with GPT OSS 120B. It's running off of my DGX Spark, still just giving it a chance to show its strengths. And yeah, so what I've already done is I've cloned this repository. All you have to do is just copy the URL from Hugging Face and then just git clone and then just the entire URL. And then this repo, I just barely found out that the structure is that the data is in its own folder here. But I figure let's just go through the README to at least understand what this data set is arranged and how it is structured, because we do need to understand that for us to be able to create data loaders out of, well, at least I assume. Here we go. Install data sets. Pip install data sets. Load the data set. How? With ds load data set. Whatever. So we don't do that. We just cloned it because we're going to point our fastai to using it similar to how the examples did it in the book. So I'm going to try to do it that way. And in my local file system, I've created two folders, a train and a valid. And what I want to do is I'm going to just maybe extract to. Okay, I'm going to extract to train on this zip file here, and that's going to give me a lot of things. Maybe I should have just pulled this all out here. Yeah, gives me a lot of folders, and each folder is going to be the Pokemon and the images associated with that Pokemon. So now you can probably understand, I guess, that these folder names are going to be our data labels, and then they're going to be the classified categories. And we'll do the same thing with valid, and I'm going to delete this as I know that valid is going to create another folder. So just drop it in here. So valid, validation data, and I think that's all there is to it, to setting up our file system for the data set. Okay, what's next? Well, I have not much of an idea in terms of how to use fastai. So we're going to take our time to understand how we were supposed to do the bear example, and then try to emulate some of that here. Yeah, let's do it. So going back to the book here, I think at some point they were importing fastai, and if we go all the way up, maybe let's see here. You know what? Let's download the notebook. Yeah. Let's just download the notebook. So we get the notebook, and hopefully we can see something here. Great. Okay, so we'll just import fast.ai vision, and we'll probably import fastbook. I think that's also the same thing for the chapter 1 here, chapter 1 intro. There should also be, yeah, the same thing, fastbook import star, and then there's also the fastai library. Where is it? Right here, fast vision all. I think this one's more important. Let's do that. So let's go back to our code. Let's just it from, and let's just tuck this. It's hard to program with one screen. Try to make the font big enough. Sorry. From fastai.vision.all import star. So let's see. All right, already we're off to a decent start. We'll just need to choose our virtual environment and hope all's well. Okay, great. We were able to import that. Now let's see if we can create a data loader from our file system. So, okay, so now here is going to be the path. In this case, our path is going to be the home directory / dataset / I think it's called Pokemon classification. So PWD, home average dev, datasets, Pokemon classification. But I think we want to drill down one more. And then this will be where we actually want to draw our data from. So let's copy that. Let's just set path to be, how do I copy? Control V. Hey, come on. I guess we can't. Oh, that's odd. Okay, there we go. Okay, there we go. Okay, so now we have that path ready. And then let's go back to here. What are we doing here? So we're going to create that label. And then we're going, so this is a function to create the label. This is to create the data loaders. I think let's try to see if we can create that data loader first. So image data loaders from name func. Okay. Path, which is going to be the file path, and then get image files path. I can't remember what that one was. So let's see. Let's just drill into it if it's there. So we'll copy and paste this just to make it easier. And then we'll modify that code. Okay, so for sure we don't need this thing here, but we do need this. So from name func, it's going to be path stir. Okay, so we got that. It's up here. We also need get image files, which I still don't know what that is. So here, get image files in path recursively only in folders if specify. Okay. Only in folders. So if I did recurse true, maybe train is probably, so DLs. Okay, let's just go back and see. Okay. So where is it? Where is it? Where is it? So var types, that's going to be our folders, path bears. Path bears black, bears teddy. So for sure, this is going to be the classification label. Okay. So get image files path. Yeah, let's just run it like this first. Okay, let's just run it like this and see what happens. So what I'm going to do is I'm going to get rid of this, and then I'm just going to declare that variable, and this is fns equals get image files path. and let's see what we get here. Cool. So we have a bunch of image files. I don't know. This is really hard to read. So let's only take the first element and see what happens. Okay, so we have a hypno, and this will be the image. So then the label will be this one here. So how do we actually build out those labels? That's what we need to find out. Let's see. So we'll have data block, get items, get image files, splitter, parent label. So parent label is going to be the function that, I don't know where they declared it at, but we could just probably make it ourselves. Yeah, maybe he already implements it somewhere. Parent label right here is a function provided by fastai that simply gets the name of the folder the file is in. Oh, okay. So it already knows that. Sure, so that will get us the labels that we need. Okay. So if we provided, let's say, for example, parent label is, maybe label equals parent label. What does that take in? An item with a parent folder name. How about we just passed in fns1? What do we get? Oh, label. Let's just print that out. Ah, there we go. Okay, so we're starting to discover things. That's great. Okay, so that's how you get the label. So therefore, if we built this data loader here, we should be able to specify, I guess, validation. That's what I'm wondering. Okay, so let's try to emulate this instead. I think this might be what we want. Let's create a data block. So instead of bears, we're gonna call it Pokemon. That'll be a data block. And then let's specify blocks will be image block, category block, probably for the label. So this is going to be the dependent, independent. Get items will be it's going to be get image files with a specified path. And I think let's specify maybe train. No, train test splitter. Let's see. Let's just say get y is going to be parent label. Okay. And then item transforms, let's resize. Instead of 128, let's just resize it to 224. Okay. Now the question is, this one is probably only going to grab, I guess, the two folders in here, train and valid. Now what I want to do is I want to be able to specify the validation and the training data. So let's just see what this API tells us here. So data block, here blocks, so item transforms, getters DL type. What is DL type? I don't think that's what we want. We want to split. So maybe let's do this. Let's ask GPT OSS. Let's see. How do I, okay, wait, let's ask. The path specified in this notebook has two subdirectories. First is a train folder and second is a valid folder. How do I create a fast AI data block considering these? I want a train. I want a data loader that isn't splitting the train data into train and valid. Okay, let's just see. Okay, so to use the two existing subfolders, train and valid as they are, you can tell fastai not to perform any automatic split and instead read the labels directly from the folder names. So path, okay, so this is going to be where our data is at, data block, so splitter is going to be func splitter. Okay, so func splitter is what we want, I think. And what is this thing here? It's just a pass through to say don't split. So then now here is going to just manually move things. Okay, valid indexes, train indexes, and then we're going to then specify the data loader. Okay. Okay, so again, I think conceptually the data block is kind of like the settings for our data loader, but we still need to initialize the data loader object after the fact. Okay, so we had to, I think this is what my conceptual block was, in that the data block isn't supposed to like know everything about it. It's just like setting up how like what your data is going to look like in terms of X and Y, how you're going to get those image files, and what is your category, and also what transformations you want to apply to them. Okay, so I think that's what your data block is for. So I should probably rename this to exactly what GPT-OSS said. It's going to be Pokemon block in this case. And I'm a bit confused about the func splitter. Let's read this comment. Does no splitting, we set splitter equals func splitter, which forces every item to stay in the training set. Then we manually assign items to appropriate loader later. Okay, let's just do that. So we won't split in this case. We'll just, because I think from what we read, automatically fastai is going to try and split the data into a train and valid. I forgot what was, I think it's 20% automatically. So we want to stop that by just providing a pass through. So we'll just return false this way. And so that's our Pokemon block. Func splitter, perhaps you forgot comma. I forgot a comma. Okay, try that again. Okay, so we created Pokemon block. Maybe we should check out what Pokemon block is. So check that out. Okay, so we create that data block. That's great. Now, build the data sets. We'll separate train and valid manually. So we'll build that data set, the sets, Pokemon block, and that allows us to have a data sets. We'll initialize a data sets object given this path, and the path is what we had defined earlier in this cell here, or yeah, this cell here, this cell here. And so executing that, cool, dataset has a bunch of images now. Great. Next, we'll just, okay, so let's see what this thing is doing here. So we're going to iterate through every single item in a data set. If the folder's parent name is validation, okay, or has valid, we append valid indexes. Otherwise, we append to train indexes. But how do we use that? Oh, we specify that in the data loader. It has properties, indexes. And then batch size 64, shuffle train, yes. Okay, this looks okay. So we're just gonna have to create arrays with indexes. So train IDX valid IDX equals a tuple of two lists. We unpack that. For I item in enumerate, we're going to look into our dataset's items. And then let's actually just print out one of them, item. Let's just do item and then break. Let's just do that. Do this first. Okay, so we have this first image here, and we can also just print out the parent.name and see what happens. That's hypno. So this item is going to be like a path in this case. Okay, so that's fine. So what we want to do then is, so that's parent name is hypno, so it's going to be parent.parent.name. That will get us whether or not it is train or valid. So because our directory it's like a subdirectory, like one level down more, and GPT OSS, I don't expect them to know that. But this is a good example, right? So that's why it's like one of those things where you shouldn't listen to AI blindly. You kind of have to use your common sense. So parent, or let's say split dir, is going to be item.parent.parent.name, and if split dir is train, we want to add train IDX, so I in this case. Else we want to add to valid IDX with I, and I think that gets us to where we want to go. As far as these things go, I am not sure if it's going to be picked up. You know what? Let's just move this away. Let's just cut, and we'll just paste this here as archive, and then let's just paste it in here, and let's not worry about it. Now we have these two. Okay, cool. Let's also now print out the length, or let's just return a tuple length of the train, and then also the length of the validation indexes. Okay, so it's 48691390. Does that match what this dataset claimed? Yes, 48691390. Great. Okay, we're getting somewhere. Okay, now we're going to create the data loader. So dls equals to dsets dot data loaders. Now we got to provide the path again. Train IDX is going to be train IDX. Valid IDX is going to be valid IDX. And then batch size, let's just leave it at 64. We'll adjust it if we somehow run out of memory. Shuffle train, we can say true. Let's ask GPT OSS, why wouldn't we also want to shuffle the validation set? I'm curious. Are you curious? Let's do that. Okay. Why do we only shuffle the training data when building the data loaders? Why not also shuffle the validation data? There's a reason for this. Okay, so let's read. We're learning about AI, so we might as well just learn something. So in a typical machine learning workflow, the training set is used by the optimizer to learn model parameters. Shuffling the training data each epoch breaks any ordering bias. All samples of one class appearing consecutively, and helps the stochastic gradient descent process see a more varied mini-batch distribution, which improves convergence and generalization. So what they're saying here is that, let's just see here, we have a text editor, or Sublime Text. Okay, so let's say this. Let's say you had A, B, C, D, E, F, G in your training or in your data set. And your batch size is 2. So I think what's saying is that if you took a batch size of 2, for example, and shuffled it, let's just maybe do something like this. BD, CE, and then what else? A, B, C, D, E, F, G. I think that's it, right? Oh, G. What else? A, B, C, D, E, F, G. Let's do, yeah, and then G finally. On epic 1, let's say epic 1, your batches will come in like this. Now, it says here, shuffling the training data each epic, right? So we're gonna shuffle it again on the second epic, and we might end up like this: A, D, F, B, C, G, and then E, and then epic 3, and so on. So that it's always going to be shuffled, but let's say if our batch size is 2, it's going to always be like a different combination. I think what happens is that in each batch size, when you backpropagate, it's based off of the gradients from this specific batch. And so when you shuffle and you grab each individual batch per epic, you actually get a better, I guess, result, because the next batch where A appears in, it's always going to be paired up with something different, and that creates like a different average. And so when it backpropagates, that's actually a different value to be adjusted, and that's how in this case GPT OSS says that it improves generalization. So it's not always the same, and because each time it's different, it's kind of like a new data or a new way of seeing things each time. But for the validation set, so the validation set, on the other hand, is meant to provide an unbiased estimate of model performance. Its purpose is to evaluate the model on data it has never seen during training, using a fixed ordering so that metrics are reproducible across runs. Shuffling validation data would not change the computed metrics, accuracy loss, etc., because those are aggregated over all samples, but it would make the evaluation non-deterministic. Each run could produce slightly different batch-wise statistics, basically per batch loss curves, and hinder debugging comparison between experiments. Yeah, because I guess it makes sense, because when you're doing validation, you don't want it to be like voodoo magic, I guess. Like you want it deterministic, so that if you're not getting the right results, at least like your validation set is stable, and it's always producing the same I guess results each time. Okay, so I'll just leave that be, and let's just move on. Okay, I don't know why I clicked on that. Okay, so we've created the data loaders. Got multiple arguments for BS. Why? What did the code say? dsets, data loaders, path, train, valid, BS, shuffle trains, true. Do we even take a BS? We do take BS. So why don't we, why does it not accept that? Got multiple values. Did I put it twice? What did I do? Is it because the ordering is not correct? Let's see here. Filter base, got multiple values, line 1. Yeah, I don't know. Let's see. Come on. Batch size, shuffle train path. So I've already defined everything. Oh, because I wasn't explicit here, because the ordering matters if you're not defining like the keyword argument. Maybe. So there you go. Maybe. Okay. So we got something else different. So default collate batch must contain tensors, numpy arrays, numbers, dicts, or lists found image, found class image. Okay, let's just pass this in. Let's see here. Control. Come on. How do I copy cell output? How about this? Too much, but let's do it. Okay, so what it's probably saying is that the data that's coming in the batch is a pillow image, and it should have been like a tensor, so it should probably be converting something here. In this case, batch transforms. I'm just gonna listen to it, which is really weird because, like, the book didn't do something like that, did it? Let's see. So, what's the problem? Batch transformations ensures each image is converted to a tensor, and normalized. Okay. Let's read the book, or at least find a reference to see if it actually did something like that. So data loaders, fine. Bears, data loaders, show batch. It didn't do that. So is there something that we did wrong? Og transforms. Wonder what's different. Maybe it's because we did the manual splitting, most likely. Yeah. It's okay. Let's actually try this Og transforms. That might be interesting. So how did they? So they provided an item transforms, and then batch transforms, Og transforms, molt2. Okay. Yeah, let's just try molt2 too. Same thing. Okay. So going back up here, we have item transforms. We're also going to have batch transforms. We're going to have Og transforms. And then molt is going to be 2. Okay. So that, maybe that'll help us out. No. Okay. That's fine. What else did he do differently? Maybe it was during the downloading process. Let's see. During the downloading process, it was probably loaded in as some sort of tensor, maybe. So verify images. Data loader. Random splitter. Let's read what random splitter is doing. So telling fastai what function to call to create the labels in our data set. Nope, that's not what we want. Valid.showBatch. So bears data loaders path. Okay, so this is okay, Pokemon block data sets. I should probably rename this to Pokemon dsets. Then Pokemon dsets. So it's easier for me to Pokemon dsets. Okay. So let's see what's going on here. So this one, can we pass it in as a list? Let's try that. So let's do Og transforms, and then maybe normalize dot from stats image net stats. Is that how we're going to do it? So we can create that. Okay, it doesn't work. Okay, still doesn't work. And I'm going to pass maybe this one in here. So I'm going to just send that over. How do I send that over? How do I send that over? To client. Add selection to chat. No. Add file to client. I'll just copy and paste. So here is how I'm creating the data block. Okay, let's see what it comes up with. It's probably going to say, oh, you're doing it just fine. Oh, let's see. Creates a list that contains another list. Our transform R returns a list. Fast AI expects a flat list. Oh, okay. So data receives raw PL images and the collate function fails. Flatten the list or concatenate the two lists when you assign batch transforms. Okay, we can just concatenate and see what happens. So aug transforms already gives us a list. Okay. Can only concatenate lists, not normalize to lists. Oh, that's true. We have to create that list. A list, concatenate the list, and that will give us back a normal list. Okay, that seemed like it worked, but still has an error. Could not do one pass in your data loader. There is something wrong in it. Please see the stack trace below. Again, it's the same thing. Huh. So I still get the same error, still only having PLL images as items in the data loader. Oh, wait, there is one thing though. Each item in the train valid folder also contains subdirectory, which is going to be used as the label for the image within it. So for example, train label 1 image1.jpg. Okay, so let's see if this was a difference for anything. Okay, so your directory layout is this. Yep, that's my directory layout. Each image's label is the grandparent folder, train valid, and parent folder label X. FastAI can handle this directory with grandparent splitter. Automatically creates the training validation sets based on the top level folder name, while parent label still extracts the actual cast label. So grandparent splitter, train valid. Okay, split by top level folder, and then to tensor. Okay, sure. Maybe. Let's see. Maybe we don't even need this then. Let's try without it. And then if it doesn't work, that's okay. Okay, so here will be grandparent splitter. So that allows us to have our train and valid folder be specified. And then hopefully that's better. So grandparent splitter got unexpected keyword arg valid. Is it called something else? Valid name, sorry. Valid name. Valid name. Do that again. Okay, so we created the data block correctly this time. Well, I think we were. And then we don't need then this part anymore. So we can just get rid of this. And we don't need this anymore either. So are we okay? Let's see. Okay, so we do need the tensors thing. So let's just do that again. So aug transforms. Let's convert it to tensors. So to tensor. And then aug transforms. Are we concatenating? Let's see here. No, we are concatenating. So we have to just do it like this. And then maybe that'll help. No. So. Oh! Let's see. Tensor category. I see it now. Tensor category. Wait, so it's fine. So still getting the type error. It wants me to do act. What is wrong? What is wrong? Let's see here. How about this? Let's just do data loader's path and then just keep everything default. How's that? Batch must contain tensors. Found class. Oh, okay. Wait a second. I noticed something. Pokemon block dot data loaders. Okay, maybe it's supposed to be like this. Oh, look at that. It works. Okay, LLM, you have failed me. I noticed that this one bears is the data block, so we just specified the data loaders and then the path. Okay. This looks more like it. This is trash. So now we're finally set up. Okay. So we have a data loader. Great. That only took a long time. Okay. Fine. The solution was to create the data loader by using the data block. Or, yeah, data block. Wait, it probably had changed to that too. I just wasn't paying attention. Let's see. Oh, yeah, it did. Okay. Never mind. Fair enough. Fair enough. It did. It did. I just wasn't paying attention. It was just me being me. Okay. I wonder then if we even need that 2 tensor thing. No, we didn't even need the 2 tensor thing, so it's fine. Okay. That's fine. Okay, so what's next? What's next? Well, let's actually see what's up, right? So let's just see some images. So this DLs is right here. This is not good. Rapid Dash was not included in the training data set. Okay. So valid show batch. How about train? Okay. So you see there's some augmentation. So there was no rapid dash? I find that hard to believe. So what I'm assuming the error is that in the training data, there was no rapid dash, but then yet in validation data, there is a rapid dash, which is bizarre. Because I would have assumed it's the same thing. So there's no rapid dash, but there's a lot right here. I wonder if there's something wrong here. Is there anybody who probably mentioned anything here? No. Let's look for rapid dash. Is there any rapid dash? In our entire data set, is there any rapid dash? So validation has rapid dash. Is there? Let's see. Rapid dash. It's still loading, so maybe there is something here. Yeah, so there is. Okay, that's odd. I'm going to do something really bad. I'm going to create a Rapidash folder here. And I'm going to just dump some of the images. Just, I don't know, just some of them. Cut. It's probably not the right way to do it, but just to unblock myself. This is classification, right? So we just need some rapid dash images. That's all we need. So we'll just place it right here. I guess we can just keep just debugging to see what else we're missing. What is this saying? Oh, we had to reload it because it has like the old information. So primate was not included in the training data set. Okay, so primate. Let's just pick some random primate ones. Just do this and then cut. Let's put it into train. Primate. I'm surprised that they don't have any of this. Okay. Rhydon was not included in the training data set. So what else? Rhydon. Okay, so I'm probably just gonna keep doing this until everything works. So I might just edit stuff out. I think that's just the process of data curation, maybe. I don't know. Let's see. Rhydon. What else are we missing? Vaporeon. Okay, so let's find Vaporeon. I hope we're getting closer. Let's see, just probably get some in the bottom right here. Okay, and then just reload again and again. You know what? Yeah, just do that. Okay, cool. Now we're clean. So Rapidash is there. Okay, so we're gonna show stuff. Was there augmentation involved in any of this? Oh no, this is validation. So if we did train again, we definitely have the stretch skew and all that stuff. Okay, so validation is just, it should still be left the same way. Okay, so that makes sense to me. Now what do we want? So this is just demonstration of augmentation. Max N8 and rows, unique, true. Okay, so training our model is going to be easy, I guess. We're just going to create a vision learner. So Resnet 18. No, let's go big. Let's go Resnet 34. Okay, so we're going to create a vision learner. And then we are going to probably go with Resnet 34 maybe. With our data loaders, we're going to fine tune for epochs, and let's see what happens. So I'm going to save this notebook, and I'm going to then now just run. Will I run out of memory? I don't know. Let's see. NV top. Okay, I am using 3 gigs of GPU memory. Okay. Okay, now what? What is wrong? Tentacool. Okay. Fine. Tentacool. Tentacool. So I was trying to validate. So let's get some tentacool in here. Actually, I want to be a little more random. Let's just do these. Okay. Tentacool, 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 tentacool. Where's tentacool? Right here. I bet you it's gonna say tentacruel is missing. I saw tentacruel. Is there a tentacruel? Yeah, the tentacruel is also missing too. So let's add a tentacruel. Okay, so I might as well. I know it's gonna fail anyway. So tentacruel, get a good number here. We don't really need that much validation data, to be honest. I think it's a little too much, but it's probably just a blind split. Vaporeon, Wigglytuff. Okay, so Weedle, Wartortle. Okay, we definitely have a few more here. Venomoth, Venonat. Okay, here's what I'm gonna do. I'm gonna just one folder here, and then let's open up another one, a new window. Data sets. Just finish this up once and for all. What are we missing here? So we have Vaporeon, Venomoth. Okay, so let's just stick in some Venomoth. Just drag it in, makes it easier. What else do we have? Venonat. Okay. Venonat. Let's just take these here. That should be enough. Okay, and then what else we have? We have Venusaur. I should have probably just combined everything. Venusaur. Let's take everything here. Done. Okay, what else are we missing? Victory Bell, Vileplume, Voltorb. Holy moly, Victory Bell. Okay, Vileplume. Okay. Voltorb, Vulpix. Vulpix. Wartortle. Weedle. Weeping Bell. Weeping Bell. What else? Wheezing. Wigglytuff, Zapdos, and Zubat. Okay, so let's work backwards. Wheezing. Coughing. It comes from coughing, right? Wheezing. Yeah. And then we have Weeping Bell. Then we'll have Weedle. Then we'll have Wartortle. That's enough. Then we'll have some Vulpix. Let's just do a lot. I like Vulpix. Vulpix is such a cool Pokemon. Actually, I think I took too much. Let's keep 2 rows worth. Okay, and then Voltorb. I think that should be good. Hopefully. Voltorb. Okay. Okay. Let's hope that's it. Let's try again. So let's reload everything again and see if we can actually make it through to validation at least. GPU memory is definitely more than enough. 3.5 gigs needed. Okay, we're missing another one. I bet you we're missing another one. Eradicate. Alright. I was prepared. So Eradicate. Oh, we're missing Rattata too. What else are we missing? Seadra. Are we missing Seadra? Yep, we're missing Seadra. We're also missing Tangela. We're missing Tauros. And that's it. Okay, so Eradicate first. Eradicate. In you go. Rattata. In you go. What else? Seadra. Oh, not many Seadra. Okay. Oh no, Tangela. Okay. Tauros. Probably not a lot either. Oh wow, quite a bit of Tauros. Just like in the game or the series. Lots of Tauros. Okay. Okay, this has to be it. This has to be it. Do we have Porygon? Let's just make sure. I just noticed that. Porygon. No Porygon. Uh-oh. Okay, for sure that's something that's gonna be complaining. Okay, Porygon. Okay, Porygon. Okay, what else? Ponyta maybe? Yeah, Ponyta. I feel like all the validations in here are the ones that are like just extracted away. Maybe that's what they did. That's my feeling. This is Poliwrath, Poliwhirl, Ekans is probably because I'm gonna just do this now. Let's check. Alakazam, Charizard, no Charizard. Charizard's right here. Ekans, where's Ekans? Ekans is here. Poliwhirl, I remember it being down here already somewhere. Poliwhirl, MNOP, Poliwhirl, Poliwrath, Ponyta, Porygon, Primate, Psyduck, no Psyduck. Okay, Psyduck. So yeah, you see, like most of the machine learning AI process is just probably messing with data like this. This is like my version of cleaning data. So yeah. Raichu. There's no Raichu, surprisingly. Raichu. Oh, surprisingly no Pikachu too. That's interesting. But that's okay. It's probably in a test set somewhere. Rapidash, Eradicate, Rattata, Rhydon, Rhyhorn. No Rhyhorn. Rhyhorn. Okay. Seadra, Tangela, Tauros, Tentacool. I think at this point we're good. Okay. Let's go one more time. Alright, let's do it. Pokemon block. Pokemon data loader. Let's train. Train a Resnet model. Come on. Yay, we went through one epic. Train loss, 4.5. Wow. Okay. I think we might need some more epics here. Let's see. Cool. It's getting better. Okay, so I'm just gonna leave it going, and then we'll check back. Oh, I don't know what that first one was then. What was that first? It says 50%, so we've done 2 out of 4. I don't know how this works. Great, so the losses are starting to look really good. Okay, nice. Should we do one more? Let's just do one more. So we can just do learn.fine tune 4 maybe, or 1. Let's see what that looks like. Can we just like start from where we left off? Well, actually, the validation loss is actually getting higher. I didn't notice that. So we're probably starting to overfit. Yeah, we're starting to overfit. Oh crap. It's okay. I'll just leave it from there. I mean, it's pretty good already, so. Yeah, that's fine. 0.52 valid train. I don't think it's gonna get that much better. So we'll just leave it as it is. Okay. So now next step is to inference. So I remember there was like a way we can spin up some UI here. So it was iPyWidgets, and we already have that installed. So let's just add an upload folder, or upload button, button upload, and let's just paste that in here. So we can just widgets. Add the code here. Import star or import. Was it iPyWidgets? Okay. Dot widgets as widgets. Okay. So then button upload is going to be here. And let's see if we can just upload a file. Let's take something. Oh, we never extracted our test set. Okay, let's extract our test set. Okay, test set here. Okay, cool. Yeah. So let's go back up. Let's extract. Okay, let's do sand slash. Okay. So now we have an image in here. Will they even know? Was there even a sand slash? So now we can grab the image. Oh, we're just faking it. Okay, so let's just take this and then show it. So we're going to display that image with this output widget. Okay, so let's just put that all in one. So let's put it out here. So this is going to take the last item in our upload data, which we only have one anyway. Okay, and then we're going to create an output widget. We want to clear the output. We're going to display it with the display function, I guess, with that image to a 128 by 28 thumbnail. And that looks about right to me. So what's next? Okay, now we want to inference. So let's take a look at, first of all, what is the class that was predicted, what index it belongs to, and the probability. So what the model actually thought from that class compared to the rest. So let's just paste that. and we need a learn inf, but we can just do learner, right? We should do learner. What was it called? Learn. Our object is called learn. Did we even print anything? There we go. Ooh, that's a lot, but it predicted far-fetched, which doesn't seem right to me. Is it because we just don't have in our training data sand slash? Oh, that's funny. We don't. We only have Cedra. Okay, let's pick another picture and then let's actually add sand slash to our training data. This is actually I wouldn't say a very good data set. Okay, so we just didn't have a sand slash. Okay, let's take something that we do have, which is Cedra. And I remember we didn't have much Cedra anyway. So how do I get rid of this? Or okay, whoa, how do I clear this? Can I clear this? Maybe add some code. Yeah, let's add some code. btn upload dot clear dot what close. Oh, okay, I see. Okay, cool. That resets it. So let's actually add that down here in case. So let's upload. Let's do Cedra again. And then, okay, we'll have Cedra. And then we want to avoid that. And what does this one predict? Articuno? No. How about this one? Let's just put that down here. Whatever. Close. Upload again. Something that actually looks like a Cedra. Maybe this one. To be fair, that does kind of look like an Articuno. Oh, did I just clear it again? Horsey. Okay, we're getting closer. Okay, maybe we just don't have enough data, but it's getting closer. Let's do something that it should know. What do we have a lot of? Let's see, what do we have a lot of? Do we have a lot of Charizard? Charizard is super popular, right? Yeah. Let's see if we can recognize Charizard. Is there any Charizard from test set? Yes, there is. Okay, this one has to work. Charizard is super popular. Yes, there we go. Charizard. All right. So our model kind of sucks, but it is better than if it was not trained, I guess. Sometimes I wonder how it would even do without fine tuning. Let's just see how it works without fine tuning. So we're gonna create another vision learner with Resnet 34. Nothing learned at all. And then let's see what we get from it. So what do we have? Arcanine. Okay, so it doesn't really know, I guess. Let's see here. Can we even provide? How about we provide no data loaders? What happens? Oh, we had to have one. Okay. That's fine. So without any fine tuning, this thing says this is an Arcanine. But with some fine tuning, well, then it finally knows what Charizard is. So I'm going to just do that cleanly here. Just get rid of this. And we just fine tune that again. And technically, we're supposed to be getting Charizard again afterwards, but it's okay. So in the meantime, let's actually clean this up a little bit. So this one should probably be down here to do a cleanup. And then maybe let's print something out. Let's say print your Pokemon is, or this Pokemon is red. And this will be a F string. Okay. Yeah. And then this one we can actually just import all the way up in the beginning. because why not? Makes it easier. Here, okay, this is fine. This helps us understand. This is to create our data loaders. This is to create show batch. This is to create our model that will actually train. And then this is, I don't know what's that. Okay, this is our upload button, which we need. Technically, we don't really need to close the upload button because we're just taking the last item here. And I wonder if it's because, actually no, this is fine. This is fine. I wonder though, like, since we're passing the image like full size, is that also affecting inference since it was trained on 224 by 224 images? Maybe let's do something. Let's actually do image.resize 224. Yeah, let's see what happens. If it becomes an image that is the same as some of the training data, I wonder what that would be. So this is tensor 5, right? Oh no, this is bad prediction. Okay, so let's try with and without resizing. So here is going to be Charizard again. What do we predict? We predict Charizard. Maybe I should have also you know what? This is not very useful. I kind of want to know the probability in this case. So 14. Let's see. 1, 2, 3, 4, 5, 6, 12, 13, 14. So it's this one here. Okay. Is it? 1, 2, 3, 4, or sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, that looks about right. So 97%. And if I were to resize the image to something that it was trained on, what would happen? Okay, it doesn't change much. Okay, so it's still quite confident. What happens if I upload, again, Cedra? It was having a hard time with Cedra before. What was the one that was predicted as Horsey? This one. Okay, but there was not much Cedra in the dataset to begin with, so maybe it's still going to predict Horsey. Yeah, it's still going to predict Horsey. That's okay. Close enough, close enough. I wonder if it's more like something that obviously Cedra, like this one, would that get us closer? Yeah, it does. Okay, cool. So it has definitely learned. I just don't think there's enough data on Cedra. So if we go back to Cedra here, there's not much, right? Like right here, it's kind of hard to tell. And even then, like this image looks very familiar. Yeah, yep, nope. It was part of our data set, so that doesn't count. You don't want the same thing. So let's pick something that's not in our data set. So this data is strange. Or did I just pick something that... Oh, that was me, I think. I was just looking at the wrong folder. Okay, so let's do this. I think I was just picking something that is not correct. Or actually it was. So this does exist. So they've mixed things. How about this? Okay, so this one gives us Horsey too. So not enough data. Let's see how much Horsey we actually have. Why is it so strong towards Horsey? Horsey. Ah, yeah, we have a lot of Horsey, that's why. Okay. Okay, so if we did this, and this is kind of not ideal, but I don't really want to go and search for images. If we expand the number of examples, okay, into Cedra, would increasing the amount of examples here make it more confident? So I'm going to pick this one here again and test and see what we get before. Or let's choose this one. Okay, so this is going to be our before, our before prediction. Our before prediction is going to be a gold duck here. Something more fair, like obviously. Okay, Seadra is fine. Okay, let's do that gold duck one. Let's try to get it so that the model can predict this picture of Seadra properly as Seadra instead of gold duck. I wonder if it was actually close that it would have been Seadra. So let's see. What was the image that we knew that was Seadra? So then if we know the index of where the probability is in for Seadra, then we can see if it predicts gold duck, how close were we, right? So this will be what, let's output tensor probs at 117, and let's see how close. So it was 0.3069, and I'm guessing that's the max. Can we actually use numpy? Let's see. Is it import numpy as np? Can we kind of just do arg np dot arg max probs, and that is what, 117? Okay, great. So that is correct. So probs at 117 was the biggest one. So 117. So yeah. So 3069, it didn't even seem that confident. Now I wonder if we go back here. Okay. This will be the gold duck prediction. So the gold duck prediction is what? Let's see. Probs are np.argmax, so that's going to be the max index of probs. So the gold duck one is 0.43. The Seadra one is 2011. Now let's see if we can push that probabilities to go more towards Seadra. Maybe if I were to not do that. Let's see, it's the same thing. Okay, cool. Resizing doesn't really matter, I have now discovered. Okay. All right, so now we have more Seadra in our data set. Let's see what happens if having more examples proves that we can do better on things that we want to do better in. So in this case, we want to do better in Seadra. And so what would happen? And also, I wonder if decreasing the batch size could also help in terms of getting more detail, more generalization. Because if it's a smaller batch size with less epochs, I'm sure it would see the data more often in this case. At least not the same data, but like Seadra related data. So we can also experiment with that too if we're not getting the probabilities that we want. But we can also do this. We can do this training, right? And then see where we're at in our terms of our probability. And then let's reduce the batch size and then see the difference there too. Like, does it actually generalize into learning that Seadra is actually looking like that? You know, that being the picture that we showed that I got mistaken as gold duck. Okay, so at some point, I think we're gonna have our training loss be lower than our validation loss. But I'm guessing if we have more Seadra data, it would probably impact the validation loss to be lower now. Yeah, it does. Okay, so there is a slightly better loss on the validation loss. But still, it's still a lot different. Cool. 21.5, that's fine. Okay, so still we have the same Seadra image. See what we get now. So yeah, it's even worse. It's even more confident that it's it is a gold duck. Wow, we just made it worse. Does it really look like a gold duck? Let's see what was the other one that we had before. I think it was, what was it? Was it this one? Yeah, this one was like 0.3, I remember. So now it's 0.75. So it's like even more confident than before that is a Seadra at least. I know I'm obsessing over this, but I mean this is how it is. Like you test and then you try to get your AI to be more smart. But I wonder if we adjust the batch size, right? Will we end up with a better result? So let's do a batch size of 16. Why not? Okay. So what is it? BS 16, one positional argument source. Can we not do BS 16? Or wait a second. Can we specify batch size? Is it batch size? Let's see here. Batch size 16? No? Let's see here. Data loaders. The data source. Data sets. Oh, yeah, we're back to that thing again. Okay. Forget it. Or, you know what? Let's learn. How do we create a data set? So, data sets. Pokemon block dot data sets. What do we use? Source. How do we create a data set? Let's see here. Data sets, data sets. Can we create a data set? Let's see. Okay, you'll also learn about dataset and datasets class. Okay, well we're not supposed to have gone through it yet. And I'm kind of lazy. So yeah, let's forget that for now. But there is something else we can do. I believe we can also change the learning rate. So why don't we experiment with that? So remember in our fine tune, I think we have our learning rate that we can put in. Was it fine tune? I think it was on this one where fine tune had 2 arguments, right? Okay. Yeah, there we go. So this is the learning rate. So I don't know what the default is actually. Let's play around. Let's do 1E. Let's do 1E 1E -3. Let's do that. Okay? And then let's just reinitialize all this, and then let's fine-tune for 4 epochs because we understand now that the 5th one is kind of just like overfitting. In fact, 3 looks better, but it's okay. So let's see what happens. I don't even know what the default learning rate is, but let's just see what happens when we just do 1E -3. What results are we going to get? So, okay, for sure we probably had started with a higher learning rate than before. So, but so now I think I'm assuming that the learning rate is smaller. I think 1E2 is probably a default. But since we're pushing lower, maybe we might hit like the right, I would say minimum in this case. At least that's my hope. Oh, that's pretty good. It is. Kind of want to now go for a fifth epic then, since this is looking pretty decent. Given that we're pushing things slower. Yeah, I'll do it. Maybe. No, probably not. Okay. That looks okay. That looks okay. Okay, so maybe we might do better. I don't know. So, gold duck. Oh, that's even worse. Yeah, you know what? Let's push. Since it looks like we have a lot of room, let's push for 6 epics. Okay, so whoa, what happened here? Oh. Okay, so I gave it one more best effort, and I found that actually you can change the batch size of your data loader with just BS. I don't know. I thought I was attempting that. I don't know what happened, but yeah, just BS equals 16, meaning that we're reducing the batch size from I think a default of 64 to 16. So we're taking 16 examples at a time, and this way we can allow for more iterations per epic. And so doing that, I reduced the number of epics needed to 5, and then also went back to the default learning rate, and the losses look much lower after the 5 epics. I don't think like after the I guess the 5th epic it wouldn't have gotten much lower on the validation loss, so whatever. Anyway, so I uploaded the same picture again, and then I inferenced, and inferencing I get 0.85 for Cedra. So finally works. Just to make sure that other things work, I'll pick something else that exists in the training data set, but not the specific image itself. So Ekans is in the test data set here, and if I were to run inference, I get a 0.9999999 confidence that it is indeed Ekans. So that's really promising. So I think we have a solid base model here. Let's just try one more thing. I think Rapidash was one of the things that gave us problems. So let's just look for a Rapidash. There is one. Nope, no Rapidash. Let's look for. I guess we had Rhyhorn, didn't we? Yeah. Let's look for a Rhyhorn. So let's pick a different one. Let's pick this one. Yeah. So we should get something. These like a Rhyhorn or Rhydon, one of those. Rhyhorn, and it looks pretty confident too. So that's great. Yeah, I ignored this. This was just for Cedra, so it's throwing us off. But yeah, this is great. Now what's next? Next is just to save the model to disk. So going back to, I guess here, was it an export? I forgot that it was called export.pkl, right? That's what we're looking for. So I'm really happy right now. I'm like super happy. Export.pkl. So learn.export, and I guess it's just export.pkl. Yeah. Okay, learn.export. So learn.export, and that should save it to, yeah, right here, the model. So how big is this model? Open containing folder. It's an 87.9 megabyte file. That's cool. And we can always reload it using load learner. Okay, so load learner. Okay. Let's see. First, let's take a look at the learn object. Okay, so learn inf. So this is a different one. This is going to be a different instance. File name is going to be just export.pkl, since it's in the same directory, I think. Yeah. So use the safe learner.load instead. Okay. Can we just do learner.load file? Oh, we had to create a new instance. I see. Okay. So do we need? Yeah. I don't know how to use this. Guess load learner is fine. Load learner. Export.pkl. Done. Okay. I don't know what it means by learner.load. But okay. So yeah, so now learn inf. We can actually call the predict method again. And I think we can just use the same image that we have. So img. That gets us back Rhyhorn. So this is a completely different object. Just to make sure, I can say del learn, right? And then this will still be good to go. All right, so we created our first classification model, a Pokemon classification. We ended up downloading a data set. We ended up struggling to make the data set actually usable. And then we had to find the right parameters to actually get a decent model. 5 epics, batch size of 16. Where is it? Batch size of 16 and a learning rate of 1e negative 2. So learn rate 1e negative 2 seems to be the magic number. Why not? Let's just create a script. Pokemon_train.py, and then let's just copy and paste everything and then make it a proper script. So copy and paste. Okay, and then path can just be straight copy and paste. We don't need these things here, but we do need these. Data block and what was it? Data loader. Okay, and then we don't need this, but we do need our learner. And then after that, we can decide to export, and that'll be our model. That's how we okay, save that. Then we have our virtual environment. We are going to, I put this in chapter 1, huh? Okay. So we're going to just run Python, Pokemon train.py, oops, Python, Pokemon train.py, and it should go. Yeah, it's probably doing it in the background. Oh, there we go. Great. So it's the same thing right here. Awesome. Okay, so that, yeah, this is about it. This is here, now right here is our training script that will then export to an export.pkl. And yeah, thank you everybody. We have something going.